Hi, everyone. Dr. Michelle Rego here from Johnson Wales University. Today's topic is meta-analysis. And our goal for this short video is not to teach you how to conduct a meta-analysis, but rather how to use one for your own quantitative research. So to start off, I wanted to give you some questions that we intend to answer. The first one, of course, is what is meta-analysis? And how does meta-analysis differ from a systematic review? And then, of course, how is this relevant to me and for the studies that I'm conducting? So meta-analysis is a term that was coined by Gene Glass in the 70s. It's defined as the statistical analysis of a large collection of analysis results from individual studies for the purpose of integrated findings. Sort of a mouthful. So literally, a meta-analysis means that it's an analysis of analyses. And if we looked at Hunter and Schmidt's definition, it's a type of systematic review. And it's a systematic review that then involves integrating findings across studies or effect sizes across those studies. So a meta-analysis is a subset or a type of systematic review. So perhaps we should take a look at systematic reviews first. So a systematic review is defined as a review that attempts to identify, appraise, synthesize all of the empirical evidence that you can find. And it's carried out in a predefined plan. So it's different than your own typical literature review in that it's trying to find everything within a defined parameter or a defined universe of a particular type of research. And that's the way Cochrane approaches their systematic reviews. They're really the gold standard. Now, this plan or this process has been identified by Prisma. And so it's a process that everyone is using, really trying to take the scientific method and use a systematized approach to reviewing the literature. Now, Prisma means it's a preferred reporting items for systematic reviews and meta-analysis, Prisma. So you can see on the right side of your screen that it's basically a flowchart. And it is allowing people, once they have completed their reviews, to publish exactly how they went about it. And so it begins with identifying studies. You have to define what is the universe of studies for the category of research that you're reviewing, that total number of records. And then from that total number that you find, how do you screen? And as you can see here, it also has steps such as making sure you remove all of the duplicates. There are so many different databases that may be relevant for studies in the social sciences or in the medical field. So what databases did you use? And then how did you make sure that you remove duplicates in a systematic way? And which studies are eligible to be included in your review? It may be that some are were sort of caught in that initial net, but aren't relative to the topic that you're reviewing. So you start with this universe of studies that you've defined, and then you narrow down and create a smaller universe. And you end up with a total number of included studies that you take to the next step, the further analysis. But you should use this flowchart, and usually it's published in an appendix, but it's good for the full transparency of your research and also so that someone else could duplicate it. I found in personal practice that your systematic review is not always nice and neat and linear, but tends to be more iterative in the process. So if we look at an example of one that I did a few years ago, so here's the Prisma flow diagram, and this was included with the published study. And we end up with 81 studies included in the meta-analysis, but we started with 2,600. So for full transparency, you know, which ones were eliminated and why is really important. Imagine if you were a researcher that is you know, prevalent in a certain area of research and you are not included. You might want to know why. And so, again, you start with casting a wide net for, it's usually a Boolean search term of anything that's relevant. So this one happened to be about cause-related marketing. cause marketing, you have all the different definitions and associated terms that leads you to your studies. And of course, there's other ways to find it. So 22 of my articles I just knew about. Right? I didn't have to search for them. So I knew that they were prestigious studies that needed to be included. I'm sure they're also included in the search, and that's why we removed duplicates. But beyond that, so we screened articles, and what I found in a lot of the duplicates and the screenings that I had is that there's an overlap between cause-related marketing and corporate social responsibility. People use terms interchangeably. And so for this particular study, if it was not a cause attached to a product purchase, then I wasn't interested. So that's why we narrowed it down even further. And then the other thing that happens, because this happened to be a global meta-analysis, is I really wanted to find studies from other countries. So when I would find, let's say, something from Germany or Spain, I would look at their references, and sometimes that would lead to additional articles. So you can sort of get caught in this loop of, once you find studies, you want to make sure that you look at all the studies that they had cited. But it can turn into a wild goose chase. So you do want to limit, how long you keep searching, and eventually you end up with that total number of studies included. So you report the K, that's the number of studies, and then the N is the total number of participants. And you can see for this one, the participants were over 22,000. So it really adds up to a large analysis, but it is much smaller than that wide net that you start with, and you have to report for transparency all the steps that you take and the decisions that you make. And so a meta-analysis is really about the production of cumulative knowledge. So we talk about standing on the shoulder of giants, right? We're all researchers in a process that over time is building research. We're learning from each other, and there can be decades of research in a certain area. So, every number of years you need to stop and really reflect and summarize all of that research and see what you can glean from it. Now, there are times when meta-analysis is performed on theory just to make sure that the theory is still holding up. For instance, in the social sciences and communication, where I do most of my research, there are a lot of communication theories that were created in the age of radio and TV. Well, do they still hold up in social media? So that's an example of how meta-analysis can really help you evolve theories as well. And of course, there's no perfect study. Every study makes its decisions, right? You include some variables and not others. They could be with different participants and different parameters. And there is error and bias in every study. You can't eliminate it. But when you bring all of these studies together in meta-analysis, the hope is that there's sort of error in different directions, and biases all coming together equal each other out. And so it allows us to make more perfect our research when we reflect and we summarize it as a whole. So here's an example, again, still keeping with the cause marketing study, of looking at, so this happened to be the relationship of cause fit on purchase intentions, and the effect size was in Pearson R and correlation. And you can see that there's a wide range of effect sizes that was found across these studies. Now, the K, so there were 12 studies in this particular bivariate meta, ended up producing an N of 3578. So quite a lot of participants when viewed in summary. And it's very different sample sizes across all of these studies, as small as 67. So I wouldn't make a huge marketing decision based on a sample size of 67 people, but when you look at a meta-analysis, you're able to kind of strengthen your research and your confidence. Different countries were included here and across different dates. So there's a lot of changes that can happen in a decade. And what are some of the assumptions that may change over time? So it's also important to look at how research and effects may be shifting over time. Again, effect sizes are not only ranging in size, but it's important to understand how significant these effects were. So when we create our weighted average, I find a correlation of 0.319. But these correlations are really they're all over the place, right? 0.7 is a lot different than 0.14. So in a meta-analysis, you're also reporting confidence intervals. And I think a confidence interval, especially with a large study, is much more informative for decision makers. So this is a great p-value, but 0.001, I'm pretty confident. But what is the range of effects that I can be confident of finding? I think that's a better way of looking at it. And that's really the difference between a p-value and a confidence interval in a meta-analysis. So here is an example of a bivariate on CRM's effect, so cause-related marketing's effect on the consumer purchase. So if my product has a cause attached, how does that impact the likelihood of purchase? So imagine that you're Procter & Gamble and you're going to decide to do some cause marketing. Well, what is the correlation or the effect, the impact that causes have on purchasing? Pretty important for a business maker, a business decision maker. So it could be as small as 0.14 or as large as 0.4. So what's important is that you not only look at this random effect size of 0.277, but also understand, well, it's a guess, it's an estimate. It's not perfect. So it could be as small as 0.14 or as large as 0.4. What I like here is it's still positive. So if I make the decision, I know that the cause, the effect it has on the product will be positive. Will it be small or large? Well, there's a range there, but we know that it will be a positive effect. When a correlation is very small, sometimes the confidence interval may show you that it could be positive or negative. So does the confidence interval sort of straddle zero? Could it be, a certain size or even negative? If there's a possibility that the effect could be negative, well, that really changes the point of view for the decision maker. So here we say that it could be smaller than we hope, but we know it'll still be positive. And if you want to make a conservative decision, you could look at that 0.14 and maybe it's still profitable even at the lower range. So ranges are important to look for when you're using the results of a meta-analysis. And as we talked about at the beginning of the video, I just wanted you to have the simple goals of understanding meta-analysis and systematic review and how they're different. So a systematic review of the literature is using a systematized process so that there's a scientific method of the way that you're finding literature and what's included and what isn't. And sometimes it stops there. It could stop with just a narrative of what you found. But the next step in meta-analysis is that it's also looking at effect sizes and the direction and the magnitude of the relationships that have been found in, let's say, a decade of research can really help you guess what you're about to find in your own study. It will help you with building studies, it helps you writing directional hypotheses, and really gives you strength to the findings. And I think also most importantly, once you're looking at your own findings, well, is this in keeping with the meta-analysis? And maybe there's more than one that have come before you. So not just one or two studies, but when you look at a summary of studies, is your research sort of validating what has come before, or is it different? If it is different, then you really need to dig and figure out why. And a systematic review is really going to help you save time. So with really any study, when you're doing a literature review, if there has been a systematic review in your topic area, you should find that and you should include it. And I think that also gives some validity to your literature review. If you're not taking the time to do a meta-analysis, someone else has in the past few years, well, that can really save you a lot of time and give you the confidence that you're not missing anything because they took the time to do a Prisma flow chart and explain exactly how they conducted their research. Thanks, everybody. So if you're interested in learning more about systematic review and meta-analysis, I would refer you to the Prisma website and also the Cochrane Library. Thanks.